Let's discover how switches learn things. I have here a switch with a network, and these numbers down here are the port numbers, 3, 4, 5, 7, and 12, that these PCs are plugged into. This is PC 1, 2, 3, 4, and 5, and then these letters down here underneath each PC represents a MAC address. This isn't really a full MAC address. This is just shortened for our purposes. A MAC address would actually have 2, 4, 6, 8, 12 letters to it, anywhere from 0 through 9, and then A through F. So these are just shortened versions. All right, so this switch, let's say, is freshly plugged in here. It doesn't know anything yet. It doesn't know who's attached to what. And so the first thing that happens here in this case is, let's say that PC5 wants to send a message out to PC2. Now it knows through ARP, which is, we're not going to get into ARP right now, but it knows that PC2 is CCCC. So it sends out a frame to the switch here. So it generates this frame, sends that on up to the switch. Now the switch has this frame, but it doesn't know yet anything about where to send it. But one thing it does know at this point, it now knows that port 12 is associated with DDDD. It records that in a little notebook it has called the MAC address table, or sometimes the CAM table. Content Addressable Memory is what that stands for. So whenever a frame comes in from a PC that it is not aware of, it adds that information to its MAC address table. So now it says, oh, the port 12 is DDDD. All right, so now what does it do? Well, it doesn't know where to send this frame yet, and so it has to ask. And it's going to send a request out to all of the PCs except the PC on which this frame came in. That's important. Always know it does not send this frame out to this PC, only all of the others. Now this is not a broadcast, this is a flood. There's a difference. A broadcast would actually be addressed to all Fs, FF, 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 FF. But in the case of a flood, it doesn't have such an address. So it floods this request out to all of these PCs except PC5. Now PC1 and PC3 and PC4 are going to ignore it. But PC2, they're going to drop the frame, but PC2 is going to send this response, this reply back to this piece, to the switch. So once it arrives at the switch, now the switch can record, oh, CCCC is associated with port 4. So it writes that in its MAC address table. Notice it's always on the incoming frame, never an outgoing frame, never an egress, but always an ingress frame on which it records for the MAC address table. All right, so now that it knows where CCCC is, it now sends this frame on up to CCCC, and that completes the process. Now, of course, if PC2 wanted to respond to PC5, it would send out a new frame with DDDD. When that frame gets down to the switch already knows where DDDD is because it already has that in its CAM table. It says, oh, that's on port 12, and it would send it out of port 12, and so on. So this is how this switch is going to learn these addresses.